In this video, we're going to see about amplifier design. Here we use a 15 voltage at the VCC, and we are given with VCE of 7.5 voltage, which is standard for BC 548 transistor, and HFE is of 350. And now we check for biasing. VCC equals VRC plus VCE plus VRE. And by doing these calculations, we get VRC equals 6 voltage, VRE equals 1.5 voltage. Now we see how to calculate the resistance values. RC equals VRC divided by IC, that gives us 600 ohm, and RE equals VRE divided by IC, that gives 150 ohm. And we find for IE, that is IC equals beta, divided by 1 plus beta, multiply with IE, that is 10 microampere. And assuming R1 equals VR1 divided by 10, IB gives us 44.9 kilo ohm. And for approximation and availability, we make use of 47 kilo ohm. Now we find the capacitor values. We know that XCB equals 1 divided by 2 pi FCB. And from this, we get the value of base capacitor values. And similar we got for collector and emitter capacitor. And now we come for the oscillator design. We just remove the input signal, and then we add a feedback tank circuit. For this, we use of a 1 millihenry inductor and 1 microfarad capacitor. In this video, we are going to see how to design the CE amplifier and Hartley oscillator. Now we will see the connections of an amplifier. This is the NI NVIS kit, and here are the ground and then power supply. Here we use the 15 voltage power supply, and then now we use the BC 548 transistor, and here is the collector base, and then the emitter, the R1 N80 R2 resistance connected to the base. R1 is 47 kilo ohm and R2 is 8 kilo ohm. Then we use the RC collector resistance of 560 ohm, and in the emitter side we use of the 150 ohm resistance. And then we use the coupling and bypass capacitor of 22 microfarad. And to generate the input signal, we use the function generator. We connect one wire to the channel A0 plus, and another wire to the input is connected to the base capacitor, and the A0 minus should be connect to ground. And to view the output, we take the output from the collector capacitor and make connection with the A1 channel. So now we can see the connections to be modified to get an LC oscillator from amplifier circuit. An Hartley oscillator must consist of 2 inductors in series and a parallel capacitor, called as tank circuit. The inductor values must be 1 millihenry and a capacitor of 0.1 microfarad. In case this not works, try to use 10 millihenry inductors and 1 microfarad capacitors. Connect one end of the tank circuit to the base capacitor. Connect the other end to collector capacitor. Then the node point of the inductor is to be grounded. Then connect the output capacitor to the oscilloscope so that the output can be analyzed.